Hello everyone to video 3 on for Stat 282 chapter 7. So here in the previous video we were given an x value and we were asked the probability or the likeliness of that x value occurring. So in this video we're going in the opposite direction. We're going to be given something else. So here we have an example. The combined verbal and quantitative reasoning score of the GRE is normally distributed with mean 151.3 and standard deviation 8.7. We are asked, what is the GRE score? So we're not asked a probability or likeliness. What is the score of a student whose percentile rank is at the 85th percentile? So remember what 85th percentile means. So what they just actually gave us is they gave us the probability that x is less than or equal to some x value is 0.85. Remember, percentile means that you are better than 85% of the population. Okay, so we're asked actually to find this x value here. We're asked to find this x value here. Okay, so the way we're going to do that is a couple ways. The first way we're going to do it is we're going to solve it by using our standardization process and using our z-value equation from before. Okay, so we'll need this equation. So z is equal to x minus mu over sigma. We're going to use that in a moment. Okay. Okay, so the first thing we need to do is we need to rewrite this. So we know if probability of x is less than or equal to x is 0.85, then also probability of z, the standardized value, less than or equal to the z value that we can calculate is also equal to 0.85. Okay, so the first thing we want to do is try to find this z value here. So we want to know the probability that it's less than or equal to 0.85. Now, in the past, you would use a table for this. You would actually go to the table, which I'm going to show, and we would find on the table, inside of the table 0.85, and we would find the z value that corresponds. So let's see what I mean by that. So here I go to the table we had before. What I could do is I could search inside the center of this table for the value 0.85. Remember, the center of this table are probabilities, and 0.85 is the area under the curve, or a probability, same thing. Okay, so here I can try to find 0.85. Right here we have 0.8508. That's very close. And then I could find the z value that goes with that. So I can go to the left, 1.0, and go to the top, 0.04. So what that tells us is the z value would be approximately 1.04. Okay, just so we didn't have to do any other calculations, we get the z value as 1.04. Now, in the calculator, we can do this differently. So we can go second distribution and go inverse normal. We did this before. Okay, so here, I'm going to put in here, I'm going to move this over. Okay, we want the area to be 0.85, and notice it is less than or equal to. That is important. That matches with what the calculator will expect. The calculator expects you have things in less than or equal to. I then am going to go down and I'm going to leave this. This should be 0, 1 by default. We're dealing with a standardized value, so it should be 0, 1. And I'm going to click enter and enter. And look, if we round, we get exactly 1.04 or approximately. Okay, so here, that is the z value we're searching for. So what we just found, though, is we found the left side of this, of this equation. Okay, so we found the left side of this. So we need to do some algebra now. We have 1.04. And we also have the mu and the sigma values, because those were given to us. We do not have the x value. 151, I believe it's 0.3. 151.3 and 8.7. Oops. I'll disregard that. Okay, so now, solving this for x, which I expect everyone should be able to do, if we do some algebra here and solve for x by multiplying both sides by 8.7 and adding 151.3, we get, and I can do this in the calculator at least, okay, well, I need, put that down there, and this over here. So here I'm going to go 1.04 times 8.7, and then I'm going to take that value and add to it 151.3. Okay, so I get 160.348. 160.348. Okay, that was a little bit of work. So we used a table to find a z-value. That's a little bit Stone Age-y, so it's not really necessary to do that anymore. We do have a calculator, so why not use it to its potential? Okay, so rather than going through this process, if we want to just check your answer, sometimes you want to have the work anyway. So one way you can check your answer, or technically do the whole problem, is I'm going to cover this guy up here. I'm going to go back to inverse normal, so second vars, inverse normal. And now I still want 0.85. We still have less than or equal to, looking on the very beginning of this problem. But now I'm going to put in our distributions, mean and standard deviation. So 151.3 and the standard deviation of 8.7. And you'll note inverse normal gives you the x value. You get 160.316, which is extremely similar to what we got here. The table, as usual, has some round off. Okay, so back to the PowerPoint. So here there is some interpretation to go along with this. Okay, so here this says that what we just found is we found the x value such that this is, if you got that, if a randomly selected person got that x value, they would be in the 85th percentile. Okay, so a person who scores 160.32 on the GRE would rank in the 85th percentile. That's the end of this video. See you soon.